Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 2 of a unit electric charges and fields. Today we will learn about the Coulomb's law. If you remember in the previous classes we have learned what are the charges, what are the basic properties of charges, kind of charges, two kind of charges. We know how to charge a body, that is the process of electrification. We know that properties of charges, we know the electrification of charges and everything. Now we will know how forces will occur or will exist on a charges. That law is given by a Coulomb. So this is what we know as the Coulomb's law. So before going to the Coulomb's law, we will just look at what are the forces and what kind of forces basically it would be. So we know basically we can categorize it into a two categories. One is the contact force, another is the non-contact force. Two kind of forces could be other. One contact, another is the non-contact. Now please think, which are the forces that can come in under the category of contact force? Frictional force, normal forces, tension forces, this all are the contact force. So this do exist if two bodies are in contact. They does not exist if two bodies are not in contact. Yes, so they do exist if two are in contact. They does not exist if they are not in contact. One is the non-contact force. What are they? They are the gravitational force, they are the magnetic force, and we can add it up. It's an electrostatic force. This all are the non-contact forces. So let us look at this electrostatic force. Now do you remember what is electrostatic? Try to remember the previous class. We have said that charges could have a two states. Either it could be in a state of rest or it could be in a state of motion. If they are at rest, this study is known as the electrostatic, and if they are in a motion, they are the current electricity. So we are here discussing electrostatic force, that we call as an electrostatic force is a non-contact force. That means two charges need not to be in contact to apply a force on each other. Who have found it? This a French scientist, Coulomb, has given this law, that this non-contact forces is known as the Coulomb's law of the forces. So on name of this we are using this. Yes, what is it? Let's say this is charge q1, this is charge q2. We said this, that if between this a certain kind of force is available, this force first thing depends on the product of these two charges. It is directly proportional to the product of these two charges. This F directly proportional to the q1 q2. Next, this depends on the distance between these two charges, but not only a distance, it depends on the square of the distance, and which is an inversely proportional. So this depends on the distance or square of the distance between these two charges, and which we can call as an F inversely proportional to the r square of the distance. So when I write these two things in a simultaneously in a one relation, I can write F directly proportional to the q1 q2 divided by r square. If I remove this proportionality symbol, I need to add one constant. So here I am writing a k, which is a constant. Generally we say this as a Coulombian constant. So this is F is equals to k multiplied by q1 into q2 divided by r square. Now value of an k, it is a 1 upon 4 pi epsilon naught. This is we pronounce as an epsilon. Do remember this. So this is epsilon. Okay, what the epsilon means, let's look. So we have learned up to this F is equals to k into q1 q2 by r square. Now we have replaced the k with the 1 upon 4 pi epsilon naught. So my final result would be f is equals to 1 upon 4 pi epsilon naught multiplied by q1 into q2 divided by r square. Epsilon naught, it is the permittivity of air or free space. It's an permittivity. Permittivity means it is a property of a medium which allows or disallows electric field to propagate. It's an permittivity of air or free space. It is having an unit. Look at this. How could I write units of epsilon naught? So do one thing. Transfer epsilon naught to a one place. This is epsilon naught. So this would becomes 1 upon 4 pi into f divide multiplied by q1 q2 by r square. If you are just going to make a unit of this, this is q1 into q2. Charge unit having in coulomb, and there are two charges, it is in coulomb square. Force, it would be a newton. Distance square, it is a meter square. So this is coulomb square into newton per meter, newton into meter square. Permittivity having a value of 8.85 into 10 to the power minus 12 for air or free space. So if I solve this, 1 upon 4 pi epsilon naught, it would be a 9 into 10 to the power 9. You just remember this, that when and when I use 1 upon 4 pi epsilon naught, it is 9 into 10 to the power 9. Clear? Any difficulties? Is there? It seems clear. Yes, let's move on. So we know that when and when force is there, it's a scalar or vector? Yes, it's a vector. So how many things vector requires? Basically it requires three things. One is the magnitude, second is the direction, and third, try to recall what all vector requires. It requires magnitude, it requires direction, as well as it requires to satisfy vector algebra. So as force is a vector quantity, we need to look for these three things. We need to look for the magnitude, we need to look for the direction, and we need to look for the vector algebra. So let's look at the vector form of the Coulombian force, of the Coulomb's force. So let us suppose this is two charges, one is the q1, another is the q2, and the separation between this q1 and this q2 is r. So q1 is the first charge, q2 is the second, and they are separated by the distance r. So when we say force on the first charge due to second charge, when I write F12, I mean to say force on the first charge due to second charge. When I write F21, this is force on the second charge due to first charge. Yes, okay. Now look at this. This is q1, it seems positive. This is q2, even it seems positive. If both the charges are positive, are they having force of attraction or force of repulsion? Yes, absolutely correct. They are having a force of repulsion. So when they are having a force of repulsion, they will try to make another charges to move away from himself or herself. So this is q1. If on this body force is acted by the q2, then this q2 will try to move q1 further away. If it is a force on q2, then this force is acted by a q1, then q1 will try that q2 should move on and move away. So when I write F12, it is 1 upon 4 pi epsilon naught q1 q2 divided by r cube into r21. Same and the same note. When I write F21, I need to write this is 1 upon 4 pi epsilon naught. This is constant k. We have used it. Multiplied by q1 into q2 divided by r cube into r12. Remember, this is a vector form. This is a vector form. That's why r cube is written. It is not a mistake, because here multiplication is there having a vector sign. So this is correct, absolutely correct. You can write it as an F12 or F21. Both are having the same value. I mean to say same value, but both are having a different directions. So these two forces are creating action reaction pair. Did you remember action reaction pairs? Yes, very good. So let's move on. These two are the charges. Let's revise and recap in a very short. This is q1, this is q2. Their separation is r. Then the force is, if I write it in a scalar form, it would be n k q1 q2 divided by r square. What I should remember is k multiplied by charge of a first body multiplied by charge of a second body divided by square of the separation between these two charges. This is F is equals to k q1 q2 divided by r square. I think it's clear. Let's move on. So as I said, they are the action reaction pair. Look at this. This is the same thing. This is R21. It's an force applied on the first charge due to second. This R12, this is the force applied by the first charge on the second. So I have written this F21 and F12. Both are having a different directions. Force on the first is acted on this direction, force on the second is acted on this direction. Both are having a different directions. If they are having a different directions and they are not cancelling each other, but they are having a same value. Look at this. Same magnitude. Yes, I'm talking about F12 and F21. Different direction, that means opposite directions, rather to say. Same magnitude, opposite directions, and acting on each other. This is all we require to produce action reaction pair. And one more thing, they are not in contact. So in previous years, a certain time, JEE as well as NEET has asked that do action reaction pairs require a contact? So when we are in a hurry, we make a mistake. Why? Because we know there are normal forces, that is mg forces. The normal 1 and normal 2 will form an action and reaction pair, and they are in contact. So we came to a conclusion that yes, if it is an action reaction pair, they should be in contact. But it's a false analysis. From here onwards, you can see that to create an action and reaction pair, it is not at all necessary that you should be in a contact. Even you can think a gravitational force. Let's think about the gravitational force between the sun and the earth. Sun is applying a force on the earth. Earth is applying a force on the sun. Both are applying a force of same magnitude. I say same magnitude. Magnitude represents the value. They are having a different, rather opposite directions. They are acting on each other. So even they are playing. They are creating action and reaction pair. But You are well aware that sun and earth are not at all contact. So please do remember a very good conceptual point that for action and reaction, two bodies does not always needed to be in contact. Yes, I think it seems clear. Let's move on. So for magnitude, what we are going to remember is when I need to use a Coulomb's law, I will remember one thing. I need to write K multiplied by charge of first body multiplied by charge of second body divide by square of the distance between these two charges. This is all I require. F is equals to K multiplied by Q1 multiplied by Q2 divided by R square. Clear? Okay, move on. So let's take a rapid revision. Read the question very fast. Coulomb's force is true only for blank charges. Which are they? Can we apply this on a moving charges? No. Can we apply this on a static charges? Try to recall. Yes, it is applicable to a static charges only, that cannot be applied on a moving charges. So when charges are raised, Coulomb law can be applied. So this would be the correct answer. Yes, those who have done correct, those who have guessed it correctly, congratulations, well done. Next, one more question. Read it very carefully. The force of attraction or repulsion between two stationary point charges is blank to the product of their charges and inversely proportional to the square. Do you remember the law? It is like this: F directly proportional to the Q1 Q2 and F inversely proportional to the square of the distance between these two. What they ask two stationary point charges, the product of their charges. They are talking about this. It is directly proportional. Yes, absolutely correct. Well done. Next question. If they have asked about the distance, it is an inversely proportional and square of the distance. Do remember square of the distance. Never make a mistake. Yes. Next, the condition that should satisfy for Coulomb's law is, look at the options, go through it and think. It is only true for the static charges. It acts along the line joining the two charges considered to be point charges. It is true for moving charges. And option D, both A and B. Think. Take your time. Take a 20 seconds and rethink. Can you do it? Are you able to solve it? Yes. Let me try. We are talking about Coulomb's law, that we know that is applicable for static charges only. But it even acts along two lines joining the two charges. So this is true. Even this is true. When these two are correct, my correct answer should be both A and B, because this is not applicable for moving charges. Does it clear? Yes? Can you do it? Okay, congratulations. Next, a charge Q1 exerts some force on a second charge Q2. If third charge Q3 is brought near the force exerted by Q1 on Q2. Okay, first understand what they are trying to ask. This is Q1, this is Q2. Let us say this. And let's say a distance between these two charges is R. Suppose certain charge Q3 is put here, and by somehow Q3 is moving towards the Q1. So does it make any difference between the force of Q1 and Q2? Now go back to the concept of action reaction pair. I have said at that place these two forces are acting on each other, not any third body is involved when we are talking about a certain pair. Let's say at this point of time I am interested in a pair of Q1 and Q2, not anyone else. So when Q3 is brought near, or let us say Q3 is brought farther away from the Q1, it does not make any difference on the force of Q1 and Q2. So reattempt the questions. They are asking a charge Q1 is having a certain force on second charge Q2. If third charge Q3 is brought near to the Q1, does it make any difference? No. The force between Q1 and Q2 remains unchanged. This would be the answer. How many of you can did it? Could you do it? Seriously? Very good. Let's move on. Let's move on to the topic. Next, force between multiple charges. Up till now, whatever we have discussed about for two charges only. That if two charges would be there, what we are going to do, we are going to just say this is F is equals to K multiplied by Q1 multiplied by Q2 divided by R square. Now if more than two charges are there, what should I do? Let's look. Let's begin for the forces between multiple charges. Let's say this is Q1, that is of 2 coulomb. This is Q2, that is of 4 coulomb. This is Q3, that is of, let's say, 8 coulomb. Separation between these two is, let's say, 2 meter, and separation between these two is again a 2 meter. I am giving a symbolic number, Q1 as an 1, Q2 as a 2, and Q3 as a 3. Suppose you need to find out a force on the second charge. So please do remember steps to do it. You need to find out force on the second. So first you need to think force on Q2 will be applied by whom? So I should say force on Q2 will be applied by first charge as well as on the third charge. So first write it down, magnitude by the forces of each. So I should write force on the 2 due to 1. I am here interested in magnitude only. Magnitude, I mean I am interested in value only at a first sight. So what it would be? I should say K multiplied by charge on the first body, it is 2 coulomb. Charge on the second body, it is 4, divide by square of the distance. Distance between 2 coulomb and 4 coulomb is 2. It's a 2 square, it's a 4. So that should be is equals to 2K. Never be in a hurry to replace a value of a K. Never. So just wait. Thus things will happen. Now you have done a first force. Now write it down, force on 2 due to the third charges. What it would be? We are here interested in magnitude only. So let's look. K multiplied by force on the first charge. It's 4 multiplied by charge of the second body. It is 8, divide by square of the distance between 4 coulomb and 8 coulomb. This is 4. So this would be an 8K. Now you have did half of the task. You have solved it for the numerical value. Now move to the second step. It is a direction. You need to find out the direction of each force. How we can do it? For that we know that if two charges, if Q1 and Q2 both are of same nature, they will repel each other. If Q1 is positive but Q2 is negative, they will attract each other. Even a reverse is true. when reverse is true. If q1 and q2 both are negative, what it would be? Yes, they will repel each other. If rather say if q1 is negative but q2 is positive, they will attract each other. So we know this, that if two charges are of same nature, what I mean is one is the positive, other is the positive. Both are positive, they will repel. Both are negative, they will also repel. If both the charges are of different nature, what I mean? I mean one is positive, another is the negative. They will attract each other. So first F21, this is force on the second due to 1. You are here interested in the force on the second charge, so please keep it hold. Whatever the motion would be, that motion would be of q2 only. q1 will not go anywhere because you are interested in the force on q2. So look at this. This is 2 coulomb positive, 4 coulomb positive. Both charges are positive. When both charges are positive, they will attract or repel. What do you think? Yes, they will repel each other. So for repulsion of q2, for repulsion on q2, q2 should move in this direction. This is force on second due to first. Now force on the second due to third charge. Look at this. This is 4 coulomb, that means positive. This is 8 coulomb, that means again positive. Both are of same nature. Yes, if they are of same nature, they will repel each other. For repulsion, 4 coulomb must move away from the 8 coulomb. I think it seems clear. For repulsion, I repeat, for repulsion, 4 coulomb charge seems to move away from the 8 coulomb. So it would be in this direction. This is force on the second due to third. Now look at this. This charge is having a two forces, F21 and F23. Both are in opposite direction. So just tell me, let us suppose this is block. This would be a 4 Newton block, 4 Newton force. This is 8 Newton force. Both are acting on same direction. So when both are acting on same direction, you will say, sir, total force is 12 Newton on a box. How this comes? You just add it up. But when the situation is like this, this is a block and this force is 8 Newton, this force is 2 Newton. What is the net force? You will say, sir, force is 6 Newton. How did you do it? It is an 8 minus 2 Newton. Yes, here the same situation arises. This is F21, here this is F23. Both are acting in different directions. So F net would be equals to F23 minus F21. This is 8k minus 2k. This is equals to 6k. And if we wish, we can replace a value of a k. What it is? It is 6 into 10 to the power 9 Newton. So you can write it as 54 into 10 to the power 9 Newton. Is it clear? Yes. What are our steps? First, we will focus on the magnitude only. So as soon as my first task is over, I would consider the directions. So first, on a first note, I need to focus on the magnitude only. As soon as it get completed, I need to switch on the directions. Based on the directions, I will decide whether I need to add up or subtract it. If two forces are in the same direction, I need to add up. If two forces are in different directions, I need to subtract it. Is it clear? Comfortable? Yes. Let's move on with more example. Let's say this is minus 4 coulomb. This is plus 2 coulomb. This is let's say plus 8 coulomb. This is my first charge, this is my second charge, this is my third charge. Distance between these two, let's say 4 meter. Distance between these two, let's say 4 meter. Okay, now I need to find out the force on the first charge. What is it? So remember our first step. Our first step is to find out who all would be there who are applying a force on the first charge. So I must know that 2 coulomb will apply a force. How? According to the Coulomb's law. Even 8 coulomb will apply a force according to the Coulomb's law. So let us first find out the magnitude. I say a magnitude. This is force applied on the first duty second. This is force applied by the on the first due to second. What I should write? This is K multiplied by, if I write a master formula, K multiplied by charge of first body multiplied by charge of second body divided by square of the distance between these two. F is equals to K Q1 Q2 divided by R square. Please focus. We are here to find out magnitude only. So I should write K multiplied by not a minus 4 coulomb. I need to write a 4 only. I repeat, even though the charge is negative, I would write it as a positive because I am here to focus on the magnitude only. So this is K into 4 multiplied by 2 divided by their distance, square of the distance. Distance is 4, its square would be a 16. So if I solve it, this is 4 and this is 2. So this is equals to K by 2. Again one more time, do not be in a hurry to put a value of K. We would put it at a very last stage. Next, force on the first due to the third charge. This is equals to K multiplied by first charge, it is a 4. Second charge, it is an 8. What is the distance between these two? This distance you need to calculate. This is 8 meter. So that should be is equals to square of an 8, which is an 64. So now this is 8 8s are 64 and this is 2. So even this is having the same value. This is K by 2. So half of the task is done. You have calculated magnitude. Now things will be for the directions on which charge particle you are about to find out the force on the minus 4 coulomb. So in whichever the direction a charge is moving, that would be of minus 4 coulomb. So let's look. This is minus 4, this is plus 2. So one charge is negative, one charge is positive. Will they attract or repel? Yes, you are correct. They will attract each other. So 2 coulomb will ask minus 4 coulomb to move towards him. This is the direction of force on one's due to second. Can you understand this? I should repeat, should I? So this is minus 4 coulomb, this is plus 2 coulomb. Both are having an opposite polarity. If both are having an opposite polarity, they will attract. So minus 4 coulomb will move towards in the direction of line connecting two bodies. It would be moving towards the 2 coulomb. So this is F12. Now let us move to the force between minus 4 coulomb charge and plus 8 coulomb charge. So here again this is minus 4 coulomb negative charge, this is plus 8 coulomb positive charge. Both charges are of opposite polarity. When they are of opposite polarity, they will attract each other. So even in this case, minus 4 coulomb will move towards the 8 coulomb. So this is, even this force is applying in this direction. So the situation is, on this charge, one force, this is F12, direction is positive x direction. another force. This is a force on first due to 3. Even this is in a positive x direction. So what I should do? Should I add or should I subtract? So F net would be is equals to F12 plus F13. This is k by 2 plus k by 2, which is a k only. Yes, this is 9 into 10 to the power 9 Newton. We did it. Yes. Did you understand this fully, completely? Okay, do one thing. You just solve this question. You just solve this question for force on the second charge. A first question, and second charge is that you know are 2 coulomb charges, and you need to also find out the force on the third charge. Okay, so what you need to do is first you need to calculate the magnitude. I mean a value. On a second step, you need to consider the direction. Once you do it, once you have a magnitude, once you have the directions, if both the forces are in same directions, if both the forces are in same direction, they will just add up. If both the forces are in opposite direction, they will be subtracted. Did you get it? So do this at your as your homework. Yes, let's move on. Now let us suppose we have a square having sides a, and on this square here charges are q, 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 and q. Yes, so we have a square having sides a by a, and this square is having a 4 charges at their corners, q, 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 q. Let us give the name to the charges. This is first, this is second, let's say this is third, and this is fourth. Does it clear? Okay, now I need to find out, let's say, force on the first charge. I need to find out force on the first charge. Think, how should I do it? What would be the situation and how could I calculate it? So what was our first task? We are always focusing on a very first manner is to find out the magnitude. So let's find out force on the first due to third. What it would be? Their distance between first and third is a. So what you will write is F is equals to K multiplied by first charge, Q multiplied by second charge, Q divide by distance between this two. This is a square, so this is equals to K Q square divided by a square. Clear? Next, F12. Next is the F12. This is K multiplied by Q divided by a square. This is again K Q square by a square. Next, F14. This is equals to K, that means the force applied on first charge due to fourth charge. This is equals to K multiplied by Q divided by, don't write it a square. Look at the separation. The separation between 1 and 4, it is like this only. Can you say this? This is 90 degree. So this seems to an hypotenuse. This is A, so its value would be root 2a. Can you calculate it? Yes, according to the Pythagoras, under root of a square plus a square should be at this value. So if I make a square of this, it should be in 2a square. So this is k q square divided by 2a square. Now think, we have done up to the magnitude. We did it. Now it's time to find out the directions. How can I do it? So first, let us consider the direction of each force. You just think it. How could I find out the direction? How could I calculate the direction, and how could I find out the directions? Just think. Can you do it? Can you do it? Let me help you. Force on the first due to third. Look at this. This is positive charge. This is positive charge. Both are having a same nature, so they will repel each other. So this charge will move farther from the third charge. To move further, it should move on this. This is force on the first due to third. Next, F12. This is force on 1 due to 2. Again, this is of plus Q. This is of plus Q. This is plus Q. This is plus Q. Both are having same nature. Again, they will repel each other. So this will move in this direction. This is force on 1 due to third. Next, force on the fourth. Force on the fourth. This is positive. This is even positive. So even this will repel each other. So this will move in this direction. This is F14. So let's redraw this so that you may able to solve it. This is the situation. This would be the situation. It would be an Q, 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 Q. Distance where A, and they are having a force such like in this direction. This is force on first due to third. In this direction, this is force on 1 due to fourth charge. And let's say this is first, second. So sorry, this is second, and this is third, and this is fourth. So this is force due to fourth charge. Yes, and this is a force due to third charge. This is F13. Yes, clear? Or should I rename it? 1 second. Yes, this is the correct notations. This is first, second, third, and fourth. So this should be F14. This should be F12, and this should be F13. Now, can you solve 3 vectors at a one shot? No, because we have a relation of 2 vectors only. Let us say this is first vector x, this is another vector y. How could you resolve it? Look at this. This is the 90 degree. So formula was r should be is equals to under root of x square plus y square plus 2xy cos theta. Yes. Okay, one more thing. Let's say if 2 vectors x and x having a theta, look at this, 2 vectors are having a same magnitude. 2 vectors are having a same magnitude. In class 11 you might have studied that their resultant would be 2 into x into cos of theta by 2. It's in half of the angle. R is equals to 2 into x into cos of theta by 2. So now here force on first due to second, it is a k q square divided by a square. This is same value as an F14. So when I add up this two vectorically, we are going to add this as an vector summation. We find out f resultant, again this is not a final answer, is equals to 2 multiplied by f into cos of theta by 2. Look at this. This is f14, this is f12. Angle between this two would be a 90 degree. So this is 2 into f into cos 90 by 2, which is a 45. So this is 2 into f into cos of 45. Cos 45, what it would be? Yes, 1 by root 2. So this is root 2 times of f. And what is f? Here it is. This is kq square by a square. So this is root 2 kq square by a square. Yes. Now one more force is left. This is f13. The situation is, when you add up this two, the resultant would be in this direction. This is the fr1, and in same direction it is parallel to this. You are having a force. This is f13. So direction of fr1 and direction of f13 are equal. Direction of fr1 and direction of f13 is equal. So when the direction are equal, they would be just simply added. So fr1, what it would be? This is root 2 kq square by a square plus f13 plus f13. What's its value? It's in kq square by 2a square. So what you can do is, you can just take a common kq square by a square. Kq square by a square. What is left? Here it is root 2 plus 1 by 2. This is the final answer. F net. I hope this is clear. So let's recall it. What we can do, how we can do. When we need to find out a force between more than two charges, we just calculate on a first note a magnitude by each charge. We need to find out the magnitude of forces. So first, when I need to calculate a force on the first charge, I just find it out the force by the second. Look at this. We just find it out force by the second, force by the third, and force by the fourth. This is simply the magnitude. You do not need to anything. When you consider a magnitude, here we are having a positive charges only. But if even we are having a negative charges, we are considered it as a positive only. So if we are having a positive charges, we need to consider as a positive. But even though we are having a negative charges, if it is there, we need to consider as a positive when we are talking about the magnitude. So first task I need to calculate, or I need to find out the magnitude by each charge on that charge. So I have calculated the force on this charges. I have calculated f13, f12, f14. On a very next step, what I did is, I need to find out the direction. So if two charges are of same nature, they will repel each other. If two charges are of opposite nature, they will attract each other. Here every charges are of same nature, q, 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 they will repel. So due to 3 it will move away, due to 2 it will move away, due to 4th it will move away. I have used one relation which is very important. If two forces are of same magnitude, let's say this is f, this is f, and they are having a certain angle theta, then this f resultant would be is equals to 2f cos theta by 2. And this is not simply for the forces, this is true for every vector. So remember this, if two forces are of same magnitude, the resultant would be 2f cos theta by 2. Then what next? I have done the mathematical calculation according to the vector algebra. How? This is first vector, this is second vector. Angle between these two is a 90. As I said, this is FR. It's an 2f cos theta by 2. I simply solve it. It would be an root 2 kq square by a square. Then what would be the value of f13? It would be an kq square by 2a square. So this is kq square by a square multiplied by root 2 plus 1 by 2. Again Newton. Yes, is it clear? Okay, so we stop this class at this point of time, but what you need to do is that in this class, in this numerical, I have find out the force on the second charge. I have find out the force on the second charge. As a homework, you need to calculate. For a practice, you need to calculate force on the first, and you need to calculate force on the third. Yes, please do it. This is very helpful. On a second, we have already written that we have calculated force on the first. You need to calculate force on the second and force on the third. This is your task. Do it. And on the last, I have find out the force on the first charge. It's your task. It's your task to find out force on the second, force on the third, force on the fourth. So please do it at your own way. First, find out the magnitude, next direction, and at last you need to add it according to the law of algebra of a vector. Yes, let's finish it. Thank you so much. Have a good day. Take care. Bye bye.